Hello students, in today's class we'll be solving the example number 3 from our NCERT textbook. First of all, we will decode the question, what the question is demanding from us and what all the conditions provided, information given in the question. So let's read out. An electric toaster uses nichrome for its heating element. When a negligibly small current passes through it, its resistance at room temperature at 27 degrees centigrade is found to be 75.3. When the toaster connected to 230 volt supply, the current settles after few seconds to a steady value of 2.68 ampere. What is the steady temperature of nichrome element? Steady temperature of nichrome element. The temperature coefficient of resistance of nichrome averaged over temperature range involved is this. So first of all, room temperature T room equals to 27 degrees centigrade, which will be converted into 300 Kelvin, that is converted into the Kelvin. In mostly chemistry and physics, when we are solving a numerical, we tend to convert all our centigrades into the Kelvin, that is our standard unit. Then the temperature it is reaching, that is steady temperature, is something which we are not aware, which we have to find out. At this room temperature, R at room temperature is given 75.3 ohm, and the current for this steady temperature I is given as 2.68 ampere, and then we have given one, that is temperature coefficient alpha as 1.70 into 10 to the power minus 4 degree centigrade inverse. That is the temperature coefficient. Temperature coefficient. Okay. So let's go on to the next one. So we have seen what all information was provided. So these are the values which we'll be needing. Now we'll see the solution. Okay. When the current through the element is very small, heating effects can be ignored and temperature T1 of the element is same as the room temperature. When the toaster is connected to the supply, its initial current will be slightly higher than the steady value of 2.68 because current at initially fluctuates. Current initially fluctuates. Okay, but due to heating effect of the current, temperature will rise. This will cause an increase in the resistance and a slight decrease in the current. In few seconds, nichrome, we have seen the property when we were reading Ohm's law. So as the temperature will increase, its resistance will also increase. So current will decrease because voltage and current are inversely proportional to the current is inversely proportional to the resistance. Okay. In few seconds, a steady state will be reached when the temperature will rise no further and both the resistance of the element and the current drawn will achieve steady values. The resistance R2 at the steady temperature T2 is given by R2 equals to voltage upon the current, that is 85.8 volt. This is at the steady temperature. Resistance of nichrome at steady temperature and current. Okay, so 85.8. Now we have to use this relation R2 equals to R1 into 1 plus alpha T2 minus T1. We know the value of R2, R1, alpha and T1. T2 is something which we need to find. Okay, we have to substitute the value. Let me derive this formula for you. We have R2 equals to R1 into 1 plus alpha into T2 minus T1. Okay, how the T2 is coming? First of all, this is here in multiplication. It will become R2 upon R1 equals to 1 plus alpha T2 minus T1. Then this is here in addition. It will become minus equals to alpha into T2 minus T1. I will solve this. It will give us R2 minus R1 divided by R1. Alpha over here is in multiplication. Here it will become in division. So it will give us T2 minus T1. Okay. So this is what the formula is. Here the formula which is used is T2 minus T1 equals to R2 minus R1 upon alpha into R1. Okay, we are substituting the given values and then we are solving. We will get this difference T2 minus T1 as 820 degree centigrade. Now this 820 degree centigrade, we are adding T1 here. This is in minus. When it will go to the other side, it will become plus. So T1 is 27 degrees centigrade as given in the question. Okay, we substitute over here and we will find that the value of T2, the steady temperature, equals to 847 degrees centigrade. Thus, the steady temperature of heating element when heating effect due to the current equals to the heat loss to the surrounding is 847 degree centigrade. That's how we are using our formulae and the properties of nichrome in the resistance. Hope you understood this question. We'll meet in the next lecture with a new topic. That's all for today. Have a good day. Bye bye.